Sure. Sujin, did you have any questions? You got here first.
Yeah, I have some questions.
Okay, go ahead.
Yeah, first, I wonder F ratio.
Mhm.
So at first, F ratio and F value is the same meaning.
Yes.
Yeah, and F ratio is a ratio of two sources of variance between and within. So are there any good F value or bad F value?
No, the F
No?
value is wholly dependent upon the degrees of freedom that you have.
Mhm.
So, there's 2 degrees. So for a T-test, there's 1 degree of freedom, right? Because you're just comparing your mean to 0, the difference to 0. And the F-test, there's 2 degrees of freedom. Because you've got your between and your error. So you've got your model degrees of freedom and your error degrees of freedom that go with the F-test. And so the degrees of freedom for the F-test will be defined, or the F values will be defined by the degrees of freedom. Let me pull up a distribution. Let me share my screen and I'll show you. Let me admit some folks here. Wow, it's getting all... Let's see. Here's a good one. There's a good one. All right, let me share my screen so you can see. And you don't need to remember this kind of, this particular thing. But if we look over here, at this top right here, F distribution, you can see that for the different degrees of freedom, you get different shapes of the F of the F curve. And so the F values that are extreme will sort of change a little bit depending upon the degrees of freedom that you have in your model. So it's not something that you need to necessarily understand, like, because here's the math behind the distribution. That's not something you need to know. What you need to know is that larger F values will be associated with smaller P values, right? Because the further out you get here, the less probability that you end up out here. And so that's why you get a smaller P value. And then something else that's kind of interesting, if you look at really large degrees of freedom, you can see the shape of the F distribution. Theoretically, it becomes a normal. This is why we like the normal curve so much, is that so many of our distributions under really large sample sizes turn into a normal distribution. But so it'll change a little bit. Most of the F distributions have this kind of shape, this blue or green, where they come straight, because it's a one-sided distribution. It's a positive distribution. So they go up a little bit and then they have very long tails.
Okay, got it.
Okay, any other questions?
Yes.
Okay, Ron, go ahead.
Well, whatever. I'm more happy to let Sujin go first.
I think she's done.
More.
You're up next, Ron. What's up?
Okay. I have several, so I can. They're probably quick answers. One is the midterm worksheet. Is that best submitted as a Word document?
Yes, just upload it, and but when you upload it later that day, I will post the answers for you.
Good. And as far as I can tell by looking at the answers I've done and reading ahead on it, we don't do any jump analysis at all. It's all given spoon-fed to us. Is that right?
In the review, yes.
Yeah, that's what I'm talking about, the review. Okay.
Yep.
Shall I wait or wait for more?
No, go ahead.
Okay, I'll unload on you. Did you notice that the sequence of the actual test in Canvas is different than the sequence in the document we downloaded to put our answers on?
Yes, and I mentioned that.
Okay, I'm sorry, I didn't hear it. I apologize.
Canvas has a couple spacers in there, but they actually call them questions.
Right.
And they're not really questions in Canvas.
Well, as long as I know that.
Yeah, you can. I mean, the text is identical, so you'll be able to figure it out.
Well, the text is not identical. There's a couple of questions that have more responses in Canvas than are present in the one you gave us to look the Word document. It's okay. I'm just saying there's a couple that have different. There's 3 answers instead of 2. Specifically, the question.
Weird.
Well, it's no big deal. I mean, it's obvious. I want to make sure that you knew and everybody else knew that. The questions are, I believe, 4. No, I'm sorry, that's not right. I think they're yes/no questions, and then there's a third alternative that says I don't have enough information. I can't tell you which questions are right now, but there's 2 that are like that. And I really don't think it'll change the outcome any, but it's important to know that there's a difference in the 2. Let me see if I can find the numbers. I wrote them down actually.
Yeah, no, I know what you're talking about. That's weird. They should be the same in both places.
Okay. Oh, here we go. 9 and 7 depends on 9 and 17 depends on whether you're looking at the. It's 9 and 17 on the Canvas version.
Okay. I'll take a look at it.
And it's 8 and 16 on the Word document version.
Okay,
so it's
I'll take a look.
On 1, but there's a different. There's 3 answers there instead of 2, as I recall.
Okay, I'll take a look.
I'm sorry. For those that are cutting and pasting or the order of the sequence of the multiple choice are different than the order and between the 2 tests. And that's probably
so the order of the multiple choice changes for every person.
I understand. Okay.
That's the way Canvas sets it up. There's no way to do that on a static Word document. When Canvas presents you multiple choice, the answers are always shuffled.
Okay.
And that's a cheating prevention.
I suspect that it probably was. I just didn't want anybody to misfire because the numerical designation is off by 1, as you've already addressed apparently, and then of course the sequence is different. Mm-hmm. So they need to look at that carefully.
So you have to read very carefully.
That's correct. Always pays to read carefully, doesn't it?
Yes, it does.
I thought you said no tricks in this. There's
not a trick. Canvasism. You guys are all in graduate school. You should be able to read by now.
I think that's all I had. I'll look in if I see any more, but I think that's it. Thank you very much.
Sure. Anybody else have questions?
And I have one more question. So,
sure.
Yeah. At the end of the review sheet, and there is bonus questions. So as a word meaning, it is bonus or an optional or mandatory questions?
For the midterm?
Yeah.
For the actual exam?
Not
the review, the actual exam. Yeah, it's a bonus question. So bonus questions mean that the points go towards that. So they'll be added directly to your midterm. You don't have to do them.
Okay, got it.
But if you're going to do it, do it right.
Yeah.
Don't just type in a sentence and expect to get some points on that.
Yeah, try to.
So the bonus questions get attached directly to the midterm. The enrichment credits for the learning checks will bring your learning checks back up, and then any of the other like sort of general enrichment credit and the class gets added to your final grade.
Okay. Of interest is the bonus question does not show up on the Word document.
No, it does not. You're correct.
Okay.
I'm not giving you extra time for a bonus.
Squeeze it in.
Now the hope is that once you've done the Word document and then you sit and you do your answers in Canvas, when you get to that bonus question, you'll be able to answer it. It's like, you know, the little Easter eggs in video games.
I don't play them. I don't know what that means.
Yeah, I don't either. Shri, go ahead.
It's on correlation again.
Okay.
But it's about the null hypothesis. Are they interchangeable? I know P, it says it stands for rho. I don't know if that's interchangeable with R.
It is.
Okay.
Yep, it is. So it's the Greek letter rho.
Okay.
R. But yes, they are interchangeable. So it could be rho. So you can use any one of these as the null hypothesis. And this R could be the fancy symbol rho. I don't know if I have my symbol font will do it right. Let's see here.
But in that same line of thought, the rho symbol,
yeah, there you go. See the difference there? It's just the Greek symbol.
It's not equivalent to P at all. Is that correct?
Nope.
Okay.
Nope. So rho is the Greek terminology, but R, it's the same thing. So it can be rho or R. It can be no association, no relationship, that the mean is our best estimate of our Y, and then the alternative has the opposite of all those. If there is an association, there is a relationship, the correlation is not 0, or that our predictor variable is related.
Okay, so I have a question about the guidelines for frequency distribution. I don't know, I'm kind of hung up on what that is. I'm sure I probably know what it is, but I'm just kind of
So how to report a character categorical variable?
Ooh.
That's a frequency. That's a count of things. So that was way, way back in the early part of the module notes and way early, but it's talking about this. So how do you report a frequency?
Oh, okay.
Yeah. And that's N in percent.
I know how to do that.
Yeah. Yeah, see, so you'll see the, like, here's the, you know, there's the word.
Frequencies. Okay. Yeah. Got it.
And
I think I overthink a lot of stuff when I'm doing this.
Yes, I agree. It's hard not to get, you guys are all such high achievers. And I think you had such an expectation that the class was going to be so complex that the simpler concepts really mystify students. Like, no, it's really just the frequency. Like, that's just this.
And along that same line, you prefer to present them as percentages, not as fractions of one.
Yes.
Is that correct? Okay.
Yep. Percentages are more interpretable to the general audience. People understand 0 to 100. They don't understand 0 to 1. If you reported 0.56, they would think you had less than 1%.
Right.
So.
I have one more and I'm done.
Okay, you can have more than one more, but I'll take the one more.
It's in my notes yesterday, I know I asked you about the alpha for correlation. And in the notes, it says that alpha is divided in half for a non-directional test. But I think you were saying that it was still staying at 0.5. So I'm a little bit confused on that.
So it's 0.05.
I mean, 0.05, yeah.
Does it say non-directional test or does it say directional test?
No, it says alpha is divided. It says, as before, alpha is divided in half for a non-directional test and not divided for a directional test. That's page 4 of 4 on module.
That's backwards. So a directional test is one-sided. So that would be if you did, need to fix those notes.
But that's the same thing that she did that's the same thing that she said. It's in the notes for the woman that did the
Dr. Austin?
Yes, I didn't know who that was, but
she's your associate dean.
Okay, I just didn't know whose voice it was. But yeah,
so this is if you look at the screen, this is a directional test, right? Where the alternative is one-sided.
Uh-huh.
And that's where you would take your two-sided p-value and divide it in half. But you don't need to do that. Almost always correlation is a two-sided test. And that's actually all that JUMP reports is the two-sided test. So if let's take a little step back here. I apologize that appears to be backwards in those notes. Okay, so remember on a t-test, JUMP gives you 3 p-values, right?
Right.
That are associated with the two-sided, the greater than, and the less than one-sided. These are your alternative hypotheses. When you fit a correlation, JUMP only gives you the two-sided because it's almost always a two-sided test. You're almost always going to ask, is this equal to or not equal to 0? Because we don't know if it's going to be a positive correlation or a negative correlation. So you'd have to have a really strong idea if you knew that it was going to be positively correlated or negatively correlated to do a one-sided test or a one-direction test. But this is just a single, this is the two-sided p-value. This is the test for this is the p-value that JUMP gives you, is for the equal to, not equal to on correlation. If you wanted to test if R was greater than 0, then you divide that p-value in half. The problem with that in JUMP is that you can't just divide this in half, because I don't know if it's 0.0001 or if it's 0.0000001. I mean, it just tells you it's less than 0.001. So there's no real easy way to divide this p-value in half. So I'm promised that this is almost always equal to, not equal to, is the correlation test. And I'll check that in the notes and make a point of mentioning it to the class. Okay. So just report the p-value as you see it normally in correlation. Just it's going to give you a p-value, and just report that. And that goes with the equal to, not equal to. And you'll just say that this correlation is not 0, and here's what it is.
So is that the same logic for the t-test as well? I mean,
the t-test, most tests you'll see, statistical tests you'll see, are two-sided tests, unless you have, we use one-sided tests in clinical trials all the time, because I only care if the new drug is better than the old one. I'm not interested in testing if it's different from the old drug. I only want to know if it's better than, right? That's a one-sided test.
right.
Right? And so we use one. I'm sorry, you were muted.
If it's greater than or less than, those are one-sided, right?
Yep. We're just looking at one-sided. And in clinical trials, all the time we design one-sided tests, because I only care that our new drug is better than our old drug. I'm not looking to see if it's different from. I only need to know if it's better than. And so we design one-sided tests in clinical trials. In most research, where if this is sort of like the first time you've done it, if you don't know what the relationship's going to be, it's a two-sided test. We're just looking to see if they're different. That's the two-sided test, because it could be less than or greater than. That's two-sided. But if you have a specific purpose, you'll see one-sided tests. Correlation is almost always two-sided.
Okay.
But again, I would advise that that level of design knowledge when you are designing grants or, you know, putting in grants for research is when you need to be working with a statistician. So if you're planning research, that's when you contact either the CCTS or whatever biostat clinic, or find yourself a statistician and cultivate a relationship. And you can work together, because there's much more involved in those decisions. Right now, we're just trying to sort of show you the options, but there's not an expectation that you would leave this class and be able to do all of this on your own.
No, I'm just trying to make sure I have it right, because on the quizzes, I've gotten it all right and I've learned it this way, and now it's not right. And so.
Well, no, so I feel like you've gotten it right because there's more than just the printed notes that you've heard. So we've talked about it. There have been demonstrations. I've given you other sheets, and I'll go back and look at that. I mean, you're understanding it if you're getting it correct.
They all say the same. Well, you'll see when you go back.
I'll have to go back and take a look.
Yeah. Okay.
I have a question. So
Sure.
Also, this kind of got me tangled up a little. I was a little confused. So when running the T-test in JUMP, in module 5, we were able to just go to, you know, fit y by x, you place the variables in, and then you hit means, ANOVA, pooled T-test.
Mm-hmm.
But when you just did it, you just hit just a T-test. So am I able to just go straight to the T-test? Like, I just didn't.
Yes, so you can. So I put out a video on which T-test to use. Did you watch that, Candace?
Oh, no, but I will. I will watch it. That probably will answer my question.
Yeah, so if you go to modules and then go to the session, there's a video called which T-test to use. So they're most of the time will give you nearly identical results. And in fact, let's take a look at it here. Oh. So you can see here, they're nearly minus 7.2649, minus 7.268. Our F value here is 7612, and here is 7622, and our P values are identical, because this is really significant. Our differences are the same. What you'll see that's different is the standard error of difference here, which is the variance that's associated with the difference between your means. The T-test, the regular T-test, lets each group have their own variance. And then this is a pooled T-test, and it tells you, it assumes, it forces them to share variability. So when you do a distribution of total cholesterol by gender, we can see that we have a standard deviation of 40.497 for females, and for males it's 39.82. So they're virtually identical. Females have just slightly more variability in their cholesterol scores. This T-test right here that says assuming unequal variance lets each gender have their own variance in the T-test.
Okay.
This one says assuming equal variance actually just uses the variability for total cholesterol.
Okay.
Doesn't do it by gender. When you have nearly identical sample sizes, these are pretty close, 3910 and 3714. If they're equal sample sizes, or if they're pretty close, they're going to give you exactly the same interpretation. The only time that you really need to be wary of using the equal variance T-test is if one of your groups is 1.5 times larger than your other one. So if I have, 100 females and 20 males, then the unequal variance t-test is probably what you want to go with. But it's not, as long as you don't have vastly different standard deviations, which you should know from having done your summary, either one is fine. Okay. And the TAs are going to go back and correct the learning checks. So if people reported the pooled F and instead it was the regular, or the pooled T and instead it was the unequal T, we'll go back and change that. The pooled t-test is very robust to departures from equal variance. So you can see here that, you know, we don't get different results here until into the third decimal place. So they're pretty consistent with one another.
Okay.
Yeah, I kind of wish JUMP would hide the regular t-test, because there's actually a test for equal variances. And I feel like the unequal variance is where the unequal variance t-test should live. Oh, there's my puppy dog. Other questions?
Based on like the research scenario, that's when we decide which directional test to use, right? Like if we have previous knowledge of which is what would make a group lesser or more, then we would know whether to use it.
Yeah. That's based on experience. And so like I said, if you have no prior knowledge, or if you don't really know, no prior evidence, this is the first experiment you've done in this, you're going to want to use a two-sided test. What's frustrating as a statistician is when we review papers, and a lot of times you'll see people say that their research question is to show that this new intervention or this new treatment or this new methodology is better than the old one. And all they talk about is improvement, and then they do a two-sided test. Like, well, then that wasn't your research question. Your research question was, is it different? That means they didn't have a statistician as a friend.
I have another question.
Okay.
So when you say look at the data, so I know that when we look at, regardless of what test we run, we look at the p-value and know whether or not to reject or fail to reject the null hypothesis. But you said that we have to look at the data to know additional information.
Yeah, to know if your significant difference is meaningful to your particular experiment and population. And that comes with it. I mean, that comes with experience and practice in your field. I don't expect you to know that right now, but what you should understand is that the statistics are a tool. It's not the end all be all of the answer. So you may decide that this correlation isn't useful to you. So while it's statistically significant, this might not be enough. I mean, age is simple, but this might not be enough for you to change what you're doing. Remember, when we go from our null hypothesis to our alternative hypothesis, when we decide to pick the alternative, we have to change something. Our current understanding is that the best estimate in this example for cholesterol is just people's cholesterol. Like, we're just going to take the mean of the cholesterol. So if we decide to go with the alternative, then before we can estimate or predict what their cholesterol is going to be, we'd have to get their age, which age isn't that hard. But you can imagine many scenarios where collecting additional variables is costly, right? And so if it's not really affecting or impacting your Y value that much, it might not be useful to you. So I'll give the example of, you may have been on this call before, but I was doing analysis for the emergency department on trying to reduce wait times in the ER. It's an ED here. And there were a number of things that were significantly associated with reduced wait time, but some of them would only reduce the wait time by a few minutes, but they'd cost the hospital $200,000 to implement. They're not going to implement that.
Right.
But there's context that goes with your data. JUMP doesn't know the context of your data. It has no idea. SAS doesn't, R doesn't, whatever program you use, it's just a computer. So you have to be aware of what this means. Because to JUMP, this is just variable X and variable Y.
Okay. So when you say we may need to add more to our analysis, is that, do you want us to say additional information outside of, reporting like T or F?
Oh yes, you need to, so take the T-test for example. You can't just say, yep, these are different. How are they different? Where are they different? What are the mean values? Is the difference meaningful here? So if I look at the mean total cholesterols for each gender, right, we're looking at about a 6-point difference, about almost close to 7. You need to report that. You need to report that males are higher than, or that females are reporting higher mean cholesterols than males. It doesn't end with the p-value. That's not the end to the answer of your question. You gotta circle back and tell me what it means.
Okay.
So if you imagine having a conversation with somebody and they said to you, gosh, I'm so interested in cholesterol between men and women. That's a strange conversation, but so interested in the cholesterol differences between men and women. And if you looked at them and said, they're different and walked away,
right,
they would say, well, how? How are they different? Well, men, women have higher cholesterol than men, and walked away. Again, they'd be like, but wait, how much higher, right? So imagine that conversation if you were the receiver of that conversation about the information you'd need to know.
I think the thing that is a little bit confusing for me is like in this data, it's a little bit easier to look at because the numbers are pretty close for females and males. But when you have one that is like, you only have, maybe like if it's across race and you only have maybe 20 people that are, of one particular race, and then you've got 100 in another, and, the numbers are spread out. It's kind of hard to look at that. Like you said, it's hard for me to look at that and say what that truly means, I guess.
Right. So tell the story. So you can say that. You can say, we're showing a statistically significant difference between whites and Asians in this particular outcome.
But the sample size for this race was smaller.
Yes.
There were only N of.
Yep. However, it's important to note that.
Gotcha. Okay.
Yeah. However, it's important to note is one of my favorite phrases in writing. Or, it's a.
Okay. Got it.
Yeah, we try not to hit you with the really hard examples in Intro to Stats. But there are plenty of times where we get significant difference, and this comes up in the ANOVA all the time, where the ANOVA says, yeah, there's something different, but then you go to find where the differences are, and your group sample sizes are so small that you can't really, you're like, eh. And that's what's called a power problem. You just don't have the power to really detect those. And plus, think about, if you were sitting in front of a doctor and they said, well, I want you to take this new medication. It's had really great results. And you said, well, how many people has it been tested in? And they said 2. Right? But if they said 2,000, you'd be like, oh, okay, well, that seems, so the weight of the evidence, right? The weight of the evidence, and there are actually analyses called weighted analyses, where you let the input that a certain group has be variable based on how many N you have of that group. The weight of the analysis is also really important. And that's what I mean when I say tell the story. We work with researchers all the time that will come in and they'll say, oh my God, that's an odds ratio of 4.8. I love it. And they just run off and want to publish it. And I say, whoa, you have such a difference here because you only had one person with the outcome. You can't go publishing and saying this, only one person had this. That's not, so you really have to, it's a whole picture thing, which is why we start you with investigating the data, looking at your distributions, your means, your standard deviations, and then we frame your question, and then we give you the T-test to help you make the decision. But then the last step is that interpretation.
Okay, so then it's the same way as we've been doing it. We have evidence of and reporting our numbers, and then going in and interpreting what we find, our findings.
Yeah, what does it mean?
Thank you.
Mm-hmm. Tell the story. Yes, Sujin.
Yeah. When I see a lead ANOVA conclusion, I can see F and DF and p-value.
Mm-hmm.
So when I see these number first time, what should I guess? For example, the study is it good quality or lower quality or?
So if you're reading a study, how do you know?
Yeah, when I see the exact number, why should I guess?
Well, so every data set is going to give you different results.
Yeah.
It's not like you can say, oh, well, in this field, you're going to get T values of this, or in this one, you're going to get an F. We don't know what we're going to get. Large test statistics, so large T value or a large F, will give you small P values. Yeah. It's just the math of the situation, right? The further further out you are in this curve, you can see here, our F is way over here. Yes. Right? So that's going to give us a very small p-value. And that's to be expected. What you have to do is read the whole paper, right? You have to understand what's their population. Where did they pull their data from? Is it representative to what you're interested in? So if you're reading a study in all 20 to 25-year-old Norwegian men, is that really applicable to your gynecology practice? Probably not. Yeah, I mean, Shree's laughing, but seriously, you have to understand that those results probably don't transfer to that population, right? Or if the study is in all whites, it's probably not directly translatable to other races. And so it might be some good evidence. You also have to look at the sample size, right? Again, so that goes to the weight. What's the N? How many people had the outcomes? So after the midterm, when we get into categorical outcomes, when we're talking about event, no event, how many people actually had the outcome versus how many people didn't have it? Because proportions, of course, you can get a 20% event rate from 10, from 5, from 10, from 20, from 100. So you really need to understand how many had the event and what was the total sample size. So it's really that whole picture. You can go straight to the results section and go, oh, they had a bunch of significant p-values, but they hold no meaning. You can see here I've done bunches of different tests and they all have this same significant p-value, but all of these, these two tests have a very different interpretation. So you really have to read the whole thing. Mm-hmm. Sorry if you were looking for a magic statistical bullet.
Yeah. Okay, thank you.
Mm-hmm. Anything else, anybody? Go forth, give your midterm a shot. I promise it'll be okay. It'll be all right. We'll get, if it's not okay, then we'll figure out a way to get it to be okay. Yep, big deep breath. Just answer each of the questions. Do the best that you can. It's a holiday weekend. Submit it and forget it.
Thank you.
Yep, absolutely.
Thank you.
Thank you.
Sure.
Thank you.
Thank
Have a good day.
Thank you.
Yeah,
Thank you.
Bye.
Bye-bye.